Well, in this section, we're going to talk about just a few things. It's kind of like the tip of the iceberg. First, we're going to talk about descriptives versus inferential statistics. Okay, descriptives are broken down into two areas, which we will get into in the next couple weeks, which are central tendencies and variability. Variabilities such as standard deviation and those kinds of ideas that how does the data vary from the mean. And then central tendencies, and some of these you've had in school already, such as mean, mode, median. And then outside the central tendencies are interquartile range and some other ideas that put everything together to let you know all about descriptives. And basically, descriptives are, in most cases, a lot about your participants and their actual thought processes, such as age, gender, race, socioeconomic. Moving on to things like, do you take insulin? How much insulin do you take? How many days a week do you take it? How many times a day do you take it? Here's a great graphics between descriptive statistics, inferential statistics, and both. If you can grab this concept, you'll understand all the portions and necessities of what we're doing. Descriptive statistics generally tell you all about your participants. Okay? Inferential statistics are generalizations and inferences about a population on a question, on, let's say, a survey. Do you believe that taking insulin will help you? Using a Likert scale test. Strongly disagree to strongly agree. Okay? We could ask just those general survey questions, but without the descriptive statistics. So let's say everybody believes that insulin is an important part of it. Okay? But that simple generalization does not give you an answer about in a more dynamic way. That's a very simple. We go from simple to dynamic. When you go in that middle and you're going to that both, you add in the descriptive of age, gender, socioeconomic, how long have you taken it, and you put them together, and now you have what we call as a story, and that's what we really build, our stories. So if you can grab the idea that there are two different things, they both are separated and you report them separately, but then you bring them together to mold together to build a story of how, let's say, older people see insulin, or how younger people see insulin, and how important it is to a young person versus an older person, and multiple ways of doing that. And that's part of what we are going to be working on throughout this semester. Well, here are some of the inferential statistics that we're going to be running. I'm not going to go into detail in this, but t-test, ANOVA, and we're going to do correlation analysis. We're going to be running t-tests such as a one sample t-test, independent sample t-test, paired sample t-test. We'll be running the ANOVA and a correlation. These are all the ideas that you need for your dissertation project. Part of running statistics is understanding generalization. And generalization is that we are going to take a sample. So let's say 30, 40, 100 people. And we're going to ask them questions. In some cases, so like the biggest statistical program out there which has data is called the Titanic. And basically Titanic looks at the first class, second class, and third class levels, and who died and who didn't, who was rich and who wasn't rich. And that would be more of a population. Okay? Population would all be if everybody in the world, something like the census was done, and you're supposed to get everybody. That would be a population. Okay? But in most cases, you're looking at a sample, and the smallest sample size in a survey you can generally have is 30, sometimes called a pilot study. It's just enough to get by. Some you're going to see 30, some you're going to see hundreds, sometimes you're going to see thousands of people that have been surveyed to get data. What's real important to remember is that we are looking at a small sample size, and we're trying to generalize that to the larger population. Okay? This would be like what you see on TV when they run presidential polls. The biggest thing about that is you don't know how many people that they brought in. So let's say it was only 1,000 people. Is that a representation of the whole? It could be a representation of the whole of let's say, a county, but not of maybe not even of a state or of the United States. So I always like to know how many people were involved when they did the poll, and that way you could point it to there. So they did 1,000, and they say, well, the approval, somebody's leading by X number of points. But if they only had 1,000 compared to billions of people, it's not a true representation. So you want to take your sample size, and there's lots of ways of doing that. You could take your sample size of 30 and be okay with that. You could take a sample size of 100, but there are power analyses, like it's called the G power, where you put in all your data and it tells you exactly how many participants you're supposed to have. And that mitigates any kind of bias. It also mitigates all kinds of different ideas of your data being skewed left and right in some ways. So understanding that, you understand population sample, now you understand sampling, and G power. Again, read your book and make sure you understand those definitions that I've just given you in this, and you'll be doing just fine as we keep moving along.